Today we're going to be graphing over an interval, and we're going to be specific to a particular interval, and our interval is going to be from negative 2 pi to 2 pi. Sometimes you'll see that written in this form, negative 2 pi to 2 pi, or other times you'll see it listed as I'm graphing from negative 2 pi up to, up to 2 pi using that inequality symbol, a compound inequality. But basically, we're just going to make the graph go from negative 2 pi to 2 pi. Remember when we talked about sine and cosine, they go on forever and ever to the left and to the right. We've only graphed over one period. But now when we graph these, sometimes we'll be graphing maybe, for instance, multiple sines or cosines, or in other instances, we could be graphing only a small little piece of that function. It all depends on, remember, that number that goes in front of theta. That's the thing that's going to change. So right now in this first example, my number in front of theta is 1. That means it's one sine function in 2 pi. Because I'm graphing from negative 2 pi to positive 2 pi, I'm going to end up looking at two sine functions when I'm done. One sine function from negative 2 pi to 0, the other sine function from 0 to 2 pi. I'm also going to have to consider the shifts in the graph that are going to change things. So instead of just seeing one sine graph, like I said, we may see more or less. Instead of just seeing one cosine graph, we might see more of the cosine or less of the cosine. But we're going to go through this process kind of the same way we did when we were graphing prior to this, where I have to look at all of the pieces. And so keep in mind that this little 1 in front here can be translated to the back. That's like adding 1. That's a separate thing. That shifts this graph up. It's going to shift it up 1 unit. And then this minus 2/3 part is going to shift the graph to the right. Because that one's the opposite of what we see there. Remember, we set that parenthesis equal to 0 and solve for it. That 3 in front, that 3 there, is the height from the center. Which is shifted up. And so it's going to go 3 above the center and 3 below the center. Again, this first thing that I looked at, the number in front of theta, if I don't see it, I assume it's 1. Keep in mind that that changes how long it takes the graph to repeat itself. So we're going to put all of this stuff together, and I kind of have to do some prep thinking a little bit, but not too much. But I've got to consider all of the parts. I do know that I'm going to go from negative pi to 2 pi, so when I make my original graph, I'm always going to give myself room on each end, and equal amounts of room, because I'm going to graph the same amount of the function on each side. I can right away do my shift. And so I could move that. I'm going to make that a little bit less thick. I'm going to move this center up 1 unit. I'll do that all the way across there. That's my new center. From that center, the amplitude is going to go 1, 2, 3 above, and 1, 2, 3 below. So if I'm numbering these, my graph is going to top out at 4. 1, 2, 3, 4. I'm using the original axis is the true original axis, and I'm numbering off of that one. And the graph is going to bottom out 3 below, so that's 1, 2, 3 below. That would be at -2, again, -2 below the original axis, but it's 3 above and 3 below the new center, and the new center was shifted up 1. Okay? Then I am going to next look at the period of this graph. And so the period of this graph is 2 pi over 1. Well, that works out kind of nicely for this first one because I want to graph it from -2 pi to 2 pi. So I can just put in my normal numbering and my normal tick marks that I've used since we started graphing, 4 of them based on the quadrants. But I'm also going to go into the negative end because I need to, again, graph from -2 pi to 2 pi, so that mirror reflects on the negative side. Okay, and then the next thing that I want to look at, and almost the last thing, and before I start to graph my function, is I want to look at that phase shift. And so I'll go back to my green and do my phase shift. And so my phase shift is when theta minus 2 pi over 3 equals 0. So that's when theta is 2 pi at 2 pi over 3. So I have to approximate where 2 pi over 3 is. Well, 2 pi over 3 is more than a half because 2 is more than half of 3, but less than 1 because 2 is less than all of 3. So I'm going to have that shifted line here somewhere. Again, just get it in the right region. I want to have a feel that you understand about where it needs to go, but I don't necessarily need to measure that out. So what I've created now is my new center that I'm going to work off of. I'm going to make the tick marks to fill the rest of the graph so everything's shifted. I'm going to do that last one there. There, I would put normally 4 on each side, but I really am not even going to use this last one because this tells me I have to stop the graph at 2 pi. So I'm sort of going to randomly just stop it in the middle of my graphing. I'm going to go back in the other direction. All these things are in between. I'm just going to keep filling those in. And so now when I graph, I'm not going to stop at the 5 points. I'm going to go in and start at my center. Sine starts at 0. It goes up to the max, back down to 0, and then it would, I'm just going to put this like little dot here, but I'm not even going to get to there because I'm blocking myself in. I'm going to go back to that green color. I'm blocking myself in at, remember, it's going to max out here at that 4 top part. It's going to bottom out here at -2, and then it's going to pinch the graph in between -2 pi and +2 pi. Okay, so now I've sort of framed out my graphing region. So I've got this piece here, and normally I would finish this off, but I have to stop at 2 pi. So I need to also go backwards. So I'm going to continue kind of in the, just follow the pattern. So this is that was at the middle up. If I would continue in the opposite direction, that would go down. Then I would go back, because that's how sine repeats itself. I'm going to keep going. Then this next one would be here. But again, I'm going to randomly stop. I'm going to be blocked in by that wall I just created. Okay, so I've got all of my parameters set in place, and now I can just kind of connect the dots. I'll start at the original center. So here's where this curve is, and it would go, but it's going to stop. It's blocked there. I'm going to continue in that other direction, and again, blocked and stopped there. So the piece of the sine that I'm looking at is this chunk that falls between -2 pi and 2 pi. Again, keep in mind that all of these numbers that we looked at, all of these things up here are going to move this graph around. It's going to adjust how we number things. It's going to adjust the starting place. It's going to adjust the top point and the bottom point. But the way I graph the sine and the cosine doesn't change other than I keep going until I fill my framed in region. Like I said, sometimes our graphs are going to be like this where we see more of the graph than we're used to seeing. And some are going to be like this piece up here that we looked at where we're going to see only a chunk of the graph. And that's the one that comes next. So look at this one in action. Again, I have to think of all the other normal pieces that I had to continue thinking about. Keep in mind that my graph is going to be from negative 2 pi to 2 pi, so I'm going to extend it evenly on each end. I know that this graph shifts up 2, so 1, 2, so I have that shifted up. Oops, I want that to be a solid. New solid center. All right. From there, it's going to go a half a unit above and a half a unit below. So if I were to do my next tick mark, I'd have it blocked in a half a unit above and a half a unit below. So this is going to be sort of a scrunchy little graph. All right, so those are my max and min sort of blocked out portion that came from moving up 2 and my amplitude of a half above and a half below. Now I have to think about the period and the phase shift. So when I do the period, remember the period is 2 pi over b. In this case, that's 1/4. So this one is 8 pi. So I'm going to do my 4 tick marks. 1, 2, 3, 4. And my last one here is going to be 8 pi. So 1, 2, 3, 4. My last one on this side, negative 8 pi. But again, this graph is only going to be graphed between negative 2 pi and positive 2 pi. And so when I finish out my numbers here, just like we've done in the past, negative 2 pi, negative 4 pi, mirror reflects in the opposite side, I have some new parameters that my graph is going to stop between negative 2 pi and positive 2 pi. But this is the period of the graph, so I have to go through the motions like I'm going to graph it like normal. I have to go through that whole process. In the first one, it was kind of nice because 2 pi was the period of the graph, so I could number that in pretty easily. But here the period is 8 pi. I only want to see the piece that goes between negative 2 pi and positive 2 pi, so I'm going to lose a whole chunk of this graph. So let's do the phase shift, and then we'll get into looking at what that final graph is going to look like. So my phase shift is when theta over 4 plus pi over 6 equals 0. So that's theta over 4 equals negative pi over 6. So I'm shifting to the left. Multiply by 4 on both sides. So theta equals negative 4 pi over 6, or negative 2 pi over 3. So negative 2/3 pi is my shift. Double check and make sure I copied that down right. Everything I think looks good. So negative 2/3 pi. Well, keep in mind that my first tick marks are at pi, which means my shift on this one, my y-axis, somewhere in between there would be negative 1 pi. So it's not even quite negative 1 pi. It's hard to sort of line up. A little bit ugly there, but there's my new center axis with my top point and my bottom point and my parameters that I'm going to stop the graph at. But I'm going to fill it all in like I normally would. So I'm going to make all my tick marks. I'm going to follow this, making all my tick marks in the spots where I think they would be. 1, 2, 3, 4. This is back here. It'd be in between, in between, in between, in between. Okay. And then I'll go through and I'll sketch my cosine graph. So we'll put that one in blue. So my cosine graph starts up here. Okay. Its next mark would be at that first tick mark over. The next one would be down here. But look, I'm already out of that parameter, so I'm not even going to continue, because it would go up and then back up to the top. That would be 1 cosine, but I'm blocking it off here. I'm putting a block there. And then if I were to continue this backwards the other way, the next point would be here, but again, it's blocked by that. So if I were to sketch this, this would look like this. and then all of a sudden it says stop. Don't continue down to that point. Over here, this would come down, but it doesn't continue to this point. Like if I could imagine that be a dotted line that would continue over there. So this is the little piece of the function between negative 2 pi and positive 2 pi that I'm going to use. Like it said when we started, that these are things you're going to kind of have to like think about. Plan out a little. Think about what's going on. Know what these things are looking like. This one says I only fit a quarter of a graph in 2 pi. Well, I only have about a quarter of this cosine graph here. A little bit more because I'm going from negative 2 pi to positive 2 pi. In fact, if I want to be specific, twice as much because I'm doing from negative 2 pi again to positive 2 pi. So 2 pi on each side of that graph. But so think about what these are going to look like as we go through. Let's move on to number 3. This is another one where it's a quarter one. This one's a sine. We're shifting up. I have an amplitude of 2. I have a phase shift to the left. So this graph is going to have, again, only a tiny little piece of the graph that we're going to show up because I can only fit a quarter of the graph in for 2 pi, but I want to graph from negative 2 pi to positive 2 pi. I'll start it the same way. I'll make that centered graph that I have. I've got to consider the vertical shift that says go up. So that's going to be my new center there. And then my amplitude will go up to 1, 2, down to 1, 2. I'm going to put that in a different color. I'm going to go with the yellow highlight so that it doesn't get too crazy looking. That last one looked a little nuts, or a little bit too much green going on there in terms of where my graph was. Okay, so there's my top out, bottom out portion. Again, that came from the amplitude and the vertical shift. Now I have to consider the period of the graph again. And so the period of the graph here is 2 pi over 1/4, just like the last one, so 8 pi. That's a 1/4. It looks like a 1/6, but 1/4. So 8 pi. So again, I'll number this, my main line here, 8 pi. 1, 2, 3, 4, negative 8 pi. 2 pi would be that first. Negative 2 pi would be that second. So now I'm going to go back to that yellow because this is going to block in this portion of the graph. So if you see, I framed in the piece of the graph that I want to see. That's the piece of that I want to see. But I have to use all of the other information to get the graph completed. So now I can think about the phase shift here. So when does theta over 4 plus 5 pi over 3 equals 0? So theta over 4 equals negative 5 pi over 3, which gives me negative 20 pi over 3. Multiply both sides by 4 to get that out. So when I think about what this is negative 6 and 2/3 pi, which means that my graph is going to shift this far over. So my start of this graph is going to be, I'm going to go and number this in. This is, remember, negative 4 pi, negative 6 pi. I'm going to shift negative 6 and 2/3 pi over. So my starting point on that graph is way over there. But wait a second. The piece I'm interested in is in here. In between, it's beyond that shift starting point. That's okay. We're just going to go through and put the points on like we would normally graph, but we'll only draw the portion that falls within the window that we're looking at. So I'm going to make the tick marks just like I normally do. They're all a little shifted off. I'll keep drawing them. I mean, you might find that you get comfortable with this and you don't need to draw as many, but then I'm going to start my sine graph. So my sine graph starts here at 0, goes up, back to 0, then goes down, back to the 0, center, and then goes up. I can stop there because now I've got all my points that are in that center. So if I'm envisioning I'm going to, this is not going to be drawn. I'm not going to see this, but this is where the graph is going to go. Where do I start the graph? Right here. Where do I end the graph? At that yellow part. So the piece again that I'm interested in is not these dots, but this. Oops, stay there. This, stay there. Try and get that out of there. See if I can do this again. It doesn't want me to. Okay, so we are going to just go over it. That's the easier way to do it. That's the only piece right here that I'm like going over and over again that I'm interested in. All these little dots are just sort of the extra thing that I needed. This right here is my solution. This is the graph from negative 2 pi to 2 pi. Okay, so we've seen it where it is just a period of 2 pi, and we've seen it where the period is a fraction of it, or 2 pi is a fraction of the whole period, so 1/4 of it. We did 8 pi. What happens if I have something like in problem number 4, where this 2 here means I can fit 2 cosine graphs in 2 pi. So I'm going to have to keep that in mind as well when I sketch my graph, because this one says I can fit 2 of them in 2 pi, which means that this would be one cosine graph. This would be another cosine graph. So this would be the one lap around the unit circle, those 4 tick marks. This would be the other. So I'm making multiple. If I had to do this, if this were 3, I'd have to think about that as the first one would be the 1, then this would be the second, and then I'd have to even extend it even further. And we have that in the next one, okay? So I'm sort of jumping the gun a little bit there, but I just kind of wanted to get that in. In fact, what I'm going to do is I'm going to erase that and then start like normal, but like I've done in the other ones. So I've got, here's my whole graph. I'm going to extend that out. Keep in mind that I'm going to fit 2 in 2 pi. So when I start to fill my things in, I'm going to account for the fact that I'm going to have double the amount to the right of the center and double the amount to the left of the center. Okay, because I can get 2 of them in there. All right, so this is shifted up 1 unit. So there's my new center. The amplitude says go 3 up from that, so that would be at 4, and 3 down from there, so that would be at -2. I'm going to put yellow on the top to block the top in, yellow on the bottom to block the bottom in, and then I'm going to work through the period and the phase shift. So the period of this graph is 2 pi over 2, or pi, but remember I have to go to 2 pi. So 1, 2, 3, 4, that's going to be pi. So I have to do a second one, 3, and that would be 2 pi. So cutting that in half, pi over 2, pi over 4, this is 3 pi over 4, and it's going to reflect the same way in the opposite direction. 1, 2, 3, 4, that's negative pi. 1, 2, 3, 4, -2 pi. So now I've got my exterior parameters here as well. So I have to graph to fill in that window. That whole yellow window has to be filled in with my graph. So the next thing I want to do is go through and find my phase shift. And these get messy, and I understand that. So just sort of take your time and work your way through. My phase shift happens when 2 theta minus pi over 3 equals 0. So that's when 2 theta equals pi over 3. So I'll divide by 2, so theta is pi over 6. So I have to figure out where pi over 6 is. Well, pi over 6 is to the right. It's not, it's less than pi over 4 to the right, so my shifted axis is there. I make all my tick marks. 1, 2, 3, 4. I'm going to keep going because I'm going to fill this graph in. Going to go in the other direction. Remember, everything's a little off, a little off, a little off, a little off. Keep going. And I have one more. I got to extend that a little further. Now I'm just going to make those dots and I'm going to fill this in. And I'm going to stop drawing once I hit 2 pi. So I'll pick my color. I'm going to go do this one in red, cosine. Cosine starts up, 0, then it goes down. Remember, I'm following the green as my guidance. And keeping going. Usually I stop after I get those 5 points made, but I'm going to keep going. And this one's actually going to go up a little, and then it'll be blocked by this yellow line. If I'm going to continue in the other direction, I just follow the pattern. Continue, because cosine and sine both, remember, they continue forever, but I'm going to have to go a little bit more down. So let's think about what this looks like. So cosine goes curve. It's going to just keep going. I'm going to keep drawing that curve. I'm not going to stop here because I need to get to 2 pi. So it's going to extend up and then it's going to block me. Just think of that yellow, those yellow sides as blocks. So here I go. Continue to graph, continue to graph, continue to graph, stop. There it blocks me. So when we were graphing these, remember this piece right here is not part of that graph. I just sort of needed to get a feel for what that sign looks like. But the yellow lines block me. In this one I had a little more room to move because of the fact that that number there was bigger, so I can fit more into pi. All right, we have one left that we're going to do together, and then your job is going to be to try these last 5 on your own and see how you do. So I've got another sine graph. Again, I'm going to start the same way. I know that I'm going to have to do this evenly in both directions because I'm going from negative 2 pi to 2 pi. Keep in mind that that's just the interval we're using again. We could have an interval that goes from negative pi to positive pi, and then that would change again what the graph looks like or what piece. Or we could go from 0 to 4 pi, and that'll again change the graph that we see. But remember, keep in mind that sine and cosine both continue forever and ever and ever, both directions. So we're just getting a chunk of the entire sine or cosine graph. Okay, so this one again moves up 1 unit. So I have a new center. According to this, I'm going to go a half above and a half below. And that was a little off. Oh well. So a half above is going to block that in, and a half a unit below is going to block that in. So this is another little scrunchy graph. Then I'm going to think about the period. Keep in mind that I have to fit 3 of them in 2 pi. So I have to keep that in mind when I'm making my original tick marks. I need enough to get 3 of those, 3 sets of 4 in here. So 1, 2, 3, 4, that would be my first graph, and that would end at 2 pi over 3. That comes from that number. So this would be 2 pi over 3. Then 1, stop, I hate when it does that. Okay, so I have to erase that and get that filled back in. Sorry about that. Okay, so we did 1, 2, 3, 4. That was 2 pi over 3. 4 tick marks. 1, 2, 3, 4. There's the next one. Think about that. 2 pi over 3 doubled would be 4 pi over 3. And then 1, 2, 3, 4. 4 pi over 3 doubled, or not doubled, 2 pi over 3 plus 4 pi over 3. I'm going to add another 2 pi over that would be 6 pi over 3 or 2 pi. Now you don't have to worry about numbering all of these little tick marks, but I do like to fill in the first 4 like we normally did. And I like to do the same thing in the backwards direction, but I have to mirror reflect all this. So 1, 2, 3, 4, negative 2 pi over 3. Then 1, 2, 3, 4. That'd be negative 4 pi over 3. And then 1, 2, 3, 4. That'd be negative 6 pi over 3 or negative 2 pi. So now I've got my end parameters here that are going to block or stop this. So this is going to continue, and I'm going to squeeze or fit as many sine graphs as I can fit into that region that I've just blocked off. Now keep in mind, if this was 5 here, I'd have to be able to fit 5 sets in there. If it were 6, I'd have to be able to be 6. It would take me 6 of these little sets of 4 to get to 2 pi. If it's a half here, it's going to take half that amount to get to 2 pi. So just kind of keep in mind what those numbers mean. That's the really most important part, keeping yourself organized that way. Okay, so then we have a phase shift. So my phase shift is going to give me my starting position, and then I'm just going to continue my graph throughout. So my phase shift is when 3 theta minus 3 pi over 4 equals 0. So that's when 3 theta equals 3 pi over 4. So I'll divide by 3, so that's when theta equals pi over 4. So when theta equals pi over 4 is my shift mark. Well, now I'm having another little bit of a hard time because I didn't number everything, so I've got to get a feel for where that is. So remember I said I like to fill in this portion here, just like we normally did when we were working through this before. So I'd cut that in half, pi over 3. Cut that in half, pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6 gives me pi over 2. You might have seen these numbers so much that you're kind of remembering them. Pi over 4 is somewhere between pi over 6 and pi over 3. So my new starting axis is somewhere between pi over 6 and pi over 3. I'll make my tick marks. Now I have a lot of tick marks to make because I have a lot of graph to make. It's all going to be off a little, remember? And then I'll go in the other direction, off a little, off a little. Keep making all those little tick marks. Extend that down, okay? And now I'm going to make a lot of dots. You know, like I said, if this were 5 or 6 or 7 or 10, you'd have that many more of those tick marks that you'd have to fill in. So I'm going to do my sine graph here. I will start at my origin, then it goes up and then down and 0 to 0 and down and 0, and you get the gist. I don't need to keep talking through this. You probably see what I'm getting at, and then I'm gonna have to continue drawing, but it's gonna be blocked. And I'm gonna continue this the other way. So think about what this looks like here. It keeps going, it keeps going, it keeps going. What's gonna happen next? This is gonna go down. I'll finish all those little, oops, went down too far. Went down too far on those. Okay. Keep following my little pattern as best I can. So this is going to continue. And if you take a look at, we've got, it fits 3 in an area of 2 pi. So if I were to count from start to finish, there should be a total of 6 sine graphs in this total span here, in that total interval, sorry, excuse me. All right, so again, I know this gets a little messy and there's a lot of stuff going on and a lot of stuff to think about, but give those 5 a try and we'll see how you do. And have a great weekend, and I will see you all on Monday. Well, I'll see some of you on Monday, some of you on Tuesday. But have a good one, and see you soon.